Hello, my name is Darinka Durán, and I will present the results of an in silico analysis of the impact of pathogenic variants in the interaction of a natural substrate and a synthetic substrate with a human alpha-L-iduronidase. IDUA is a glycoside hydrolase involving the sequential degradation of the glycosamine glycans heparan sulfate and dermatan sulfate. Deficiency in IDUA enzyme activity leads to an organ dysfunction known as mucopolysaccharidosis type 1 or MPS 1. The diagnosis and prediction of the MPS1 phenotype has been supported by in vitro assays of IDUA enzymatic activity using the synthetic substrate for MUI. However, there is a significant number of variants that show no correlation between enzymatic activity and the phenotype developed by patients. This occurs mainly with variants that are outside the enzyme's active site. To assess the impact of some variants on the binding of a natural substrate and a synthetic substrate, 15 nanoseconds molecular dynamics run was carried out, and subsequently, molecular dockings were performed with representative structures of IDUA wild type and the variants serine 633 leucine, punin 533 arginine, and serine 633 tryptophan, which are related to the mild, intermediate, and severe phenotypes of MPS 1, respectively, at different times of molecular dynamics. These variants have the peculiarity of being located outside the catalytic site of IDUA. Complexes with a dermatan sulfate-derived disaccharide were obtained for all the evaluated structures with a binding delta G that can be allied with the corresponding associated phenotype for each variant, where a higher binding energy implies a lower affinity of the complex, which correlates with a worse phenotype. When the size of the evaluated ligand increased to a dermatan sulfate-derived tetrasaccharide, energetically favored complexes were obtained only for some of the molecular dynamics structures of IDUA wild type and the variant causing the mild disease phenotype. These results agree with what was expected for the intermediate and severe MPS 1 phenotypes, where the catalytic activity of IDUA should be significantly lower, which would correspond to the punin 533 arginine and serine 633 tryptophan variants. However, molecular dockings with synthetic substrate for MUI allow the formation of complexes for all the variants with a binding delta G close to those obtained for the wild-type structure. In conclusion, the synthetic substrate for MUI could bind to any of the variants located outside the active site with energy similar to those observed for the wild-type enzyme. Thus, it is not capable of sensing changes in IDUA that are outside the catalytic pocket of the enzyme, explaining the lack of correlation between the results of the enzymatic activity and the phenotype presented in patients with some variants of MPS 1. A better understanding of the regions of the enzyme that are important for the binding of the natural substrate would allow the design of substrates that improve performance in supporting the diagnosis of the MPS 1 phenotype that patients could develop. Our results suggest that a larger synthetic substrate might be able to sense changes in the region where the glycosamine glycan chain is binding, allowing to correlate enzymatic activity with an MPS 1 phenotype as a part of a complete early diagnosis that allows the establishment of an efficient therapeutic intervention. And well, that would be all from me. Thanks for your attention.